Okay, so in this example, ladies and gentlemen, for number question, was it 58? All right, if you guys get stuck on problems like this, again, I asked you guys to solve these, or we're solving them. If you get stuck with your trigonometric functions, what I recommend is that you wrote them and replaced your trigonometric functions with variables. That's it. Now we have an equation that's something that's a little bit more familiar with you. You guys spend a lot of time in these in Algebra 2. You spend some time in them in Algebra 1. And I gave them to you over your summer assignment, and also gave you a quiz at them at the beginning of the year, making sure that you guys know how to solve these by factoring. Now, hopefully we can factor it. Otherwise, we'd have to use the quadratic formula, which wouldn't really be that fun with trigonometric functions. However, I look at this, and since I have practiced factoring so many times, I realize, oh, I can actually factor this. Not that bad. Does the factoring with the variable x kind of make some sense? OK, well, guess what? That's all we're doing. All I did was replace x's or signs with x's. So guess what? If I factor it with the variables, because that's the way factoring makes sense for me, I can just replace my factored form. Instead of x's, I can replace them with signs. So therefore, I can go back to this and say 2 sine of theta plus 1 times sine of theta plus 1. Does that make sense? Yes? No? What doesn't make sense? Where? Do you understand how this is the same format as my problem? I just replaced x with sine. And then I just go back to it. It's called substitution. I'm basically just substituting a variable in for a function. OK? Good? OK. Now, what would be the next thing we do here? We would apply what? Zero product property. Can I erase this, though, now? Are you guys all good with this? OK. So what do you think we would do here? The zero product property by setting them both equal to 0. So yes, to save a little work, I can say sine of theta equals -1/2. And sine of theta equals -1. Now remember, this problem 58 was finding all the solutions, right? Mm-hmm. OK. All solutions. So when finding all solutions, we're going to want to find all the solutions between 0 and 2 pi first. So remember, these equations, what we did in 4-8, I believe, as well as that, we're looking for what angles produce a value, bless you, of -1/2. What angles produce a value of -1? So to understand that, it's important to go to the unit circle. Now again, as I mentioned, we only really need to know that first quadrant. If you guys know the points on the first quadrant, you know that square root of 3 over 2, comma 1/2, square root of 2 over 2, comma square root of 2 over 2, and 1/2, comma square root of 3 over 2. And then we know this is 1, comma 0, and this is 0, comma 1. Now, remember, sine represents the y coordinate, correct? So they're asking us, what angle is sine equal to 1/2? Well, I know here it's 1/2, but it's not negative, right? However, what I can do, though, is I know it's going to have the same reference angle as pi over 6. So what angles have the same, or what angles then? Where's another blue colored mark? Here we go. So my two angles then, remember, for sine to be negative, for the y coordinate to be negative, it has to be my two angles down here. Would you guys agree with me? And if it's the same coordinate as this, that means the reference angle is exactly the same. Would you guys agree with me on that? So all it is a reflection of these points. All right, well now, let's look at these answers, because it's really not that bad. Here, we know that pi over 6 is not a solution, because that equals +1/2. If halfway around the circle is pi, right, in terms of 6 would be 6 pi over 6. Caitlin? 6 pi over 6. So therefore, halfway around the circle is 6 pi over 6. Add an extra pi over 6, you get 7 pi over 6. So I can say theta equals 7 pi over 6. Let's do the next answer. If all the way around a circle is 12 pi over 6, but I'm 1 pi over 6 short, then that's going to be 11 pi over 6. Whenever I'm writing down all the solutions, I always write them in this vertical way, because I'll explain that in a second. And then the last one, what about when sine is equal to -1? Well, if you guys look at it, here, this point is 0, 1. This one is 0, -1. Well, if halfway around a circle is pi, then that's pi halves. Pi halves, 2 pi halves, 3 pi halves. Does everybody agree with me on that? Yes? No? Now, they're asking you to find all the solutions. I only found the solutions, ladies and gentlemen, on between 0 and 2 pi. So my solutions are basically lie on this line, that line, and that line. So if I say, all right, if I say 7 pi over 6 is one angle, how do I find the next angle? How do I find the next angle that would give you the same terminal side? You'd have to add 2 pi. You have to go all the way around again, right? And you have to keep on doing that. And I'd have to keep on doing that for all three of my angles. So all three of my angles are plus 2 pi n, plus 2 pi n, plus 2 pi n. Does that make sense why we're adding 2 pi to each one of them? Yes?
Wait, I'm kind of confused on how you got the 3 pi over 2.
Halfway, all the way halfway around the circle is pi, right? So this is pi halves, right? So 1 pi over 2. So 1 pi over 2, 2 pi over 2, 3 pi over 2. And the y is -1. Anybody have any other questions on this? Yes?
For the sine theta equals -1/2, you said it was pi over 6 when it was here.
That's like the reference angle, pi over 6. But at pi over 6, the coordinate point is square root of 3 over 2, comma 1/2. But we're looking for answers where it's negative. That's why I took that, and that's why I used these 2 points. Because these 2 points have the same reference angle of pi over 6, but they're in the third and the fourth quadrant, so the y coordinate's negative. And then I just had to find out what those angles were. But they're going to have the same reference angle as pi over 6. Does that kind of make sense? Yes?
So if it's not consistent, like you can't say, pi over 3 plus pi over 6, and you just go to those, you can just...
You mean like from here?
Yeah, if it's not consistent.
Yeah. See, the problem is you could say that, oh, from here to here is like pi over 3, right? And then from here to here is pi over 3. But the problem with writing that is because if you add pi over 3 again, you don't have a solution. So yeah, since it's not consistent, you can't do like plus pi n or plus pi thirds n or so forth.
You can split it up.
So you'd have to do them all separately, 2 pi n. I'll do, let me give you, like, did I do the tangent plus or minus 1 example for you guys?